We've talked a lot about set unions and intersections, differences and complements. So now I'm going to talk about using Venn diagrams to visualize those. So Venn diagrams are named after their inventor, who's John Venn. We've got a picture of in the corner here. And they just give us a way to visualize these different sets. So if I have two sets to draw the Venn diagram, I'm just going to draw two overlapping circles. Each circle represents one of my sets, so I can label them with A and B here. I also have the option to draw this box going around the outside, and that's going to represent my universal set U. So when we're dealing with complements, we might want to do that. Now, I'm going to go ahead and just redraw this picture so I can think about what the union, the intersection, and the difference look like. So for the union, A union B is going to be everything in A and also all of the stuff in B. So either if something is in A or B or both, it's going to be in the union. So I can shade in my Venn diagram to represent the union of those two sets. For the intersection, I'm going to again just redraw my Venn diagram here. The intersection is just the stuff that's in the overlap between A and B. So that's going to be the intersection of A and B. And finally, for the set difference here, let's move this down a little bit so we can see it. If I want to do A minus B, draw our Venn diagram. I'm going to take all of the stuff in A, but I'm going to get rid of the stuff that's in B. So I'm just left with the stuff that's in A, but not in B. So this is again my A and my B. And then separately, if I wanted to do B minus A, we've seen that those are not the same. I can start with all of the stuff in B and then get rid of the stuff that's also in A. So this gives us an easy way to really see that B minus A and A minus B are not the same as each other. Let's look at the Venn diagram for 3 sets. When I'm going to draw a Venn diagram for 3 sets, I need to make sure I have each of the different opportunities for overlap. So I need some places where A and B are overlapping, some places where A and C are overlapping, B and C, and then a place where all 3 are overlapping. So this is the general picture that we get when we're talking about the overlap of 3 different sets. I've drawn it a bunch of times so we can do some examples here. So let's say I want to do A union B intersect C. So first we can think about finding B intersect C. So I know B intersect C is that overlap between B and C. So that's going to be this section. And then we're also going to include A. So I can color A in as well. And because I'm taking the union, I want things that are either in A or in B intersect C. So if I go ahead, I can shade that in. So I have the stuff that's either in A or the stuff that was in the intersect. So I'm just going to use this picture down here to kind of finalize that. Okay, moving along here. Let's say I want to do A union B intersect C. So again, the first thing I'm going to do is I'm going to color in A union B. So that's the stuff in A and the stuff in B. So that's my A union B. And now I need to intersect that with C. So what I can do is I can just color in the stuff that's also in C as if I was doing a union. But then what I'm looking for is the stuff that's actually overlapped between the two. So if I'm just looking at that overlap, I'm looking for the stuff that both got colored in purple and in pink there. So that's going to be that stuff in the middle. So I can kind of color this section in. This is the stuff that's in A union B, but also in C. Okay, going forward, let's try A minus B intersect C. So again, my outer symbol here is an intersection. So the first thing I'm going to do is just color in A minus B, so the stuff in A, which is not in B. Then I can also color in the stuff that is in C. And I'm looking for the stuff that is in both C and A minus B. So I notice the stuff that's in both is this little section right here. So that is going to be my A minus B intersect C. Okay. Again, I'm just sort of drawing the finalized versions below for each of these. Finally, if I want to do A union B minus C, I can start with my A union B. So that's everything that's in A or B. And now we know we want to get rid of the stuff that's in C. So instead of looking for the overlap here, I'm looking for the stuff that's still in A or B, but no longer in C. So we have to remember sort of what we're doing as we're doing it. So I'm looking for that stuff that was in A or B, but not in C. So I can use these Venn diagrams to really help me picture what's going on in these different sets. Okay, finally, let's look at Venn diagrams for these two different sets here and see if we can show that they're equal by considering those Venn diagrams. So let's go ahead and draw that a little thinner. I can draw my basic Venn diagram, A, B, C. And I want to look at A union B intersect C. So I know that B intersect C is going to be this region here. Maybe we can color code that a bit. That's my B intersect C. And I'm unioning that with A. So I'm also including all of the stuff that was in A. So this is my A union B intersect C. Now let's go ahead and think about the other side here. I've actually got a little typo, so let me go ahead and fix that so that we can actually prove a true statement. So I'm going to change this to an intersect here. What I'm going to do is this one has this intersect as the sort of the last thing. So I know that in the end I'm going to have to look at an overlap. So I might want to do this twice, sort of some scratch work, and then my final Venn diagram. So I'll draw that twice so that we can do that. So first, I'm just going to think about my A union B. So A union B is the stuff that's in A together with the stuff that's in B. So that's A union B. Now let's also think about A union C. So A union C, maybe I'll do that in some dots here. A union C is going to be the stuff that's in A or the stuff that's in C. And now I'm looking at the intersection of those two sets. So I'm looking for the stuff that got both green and yellow. So we overall get this region here. We get all of A, and then we get this little extra piece that's in B union C. So we can see from those two diagrams that those are going to be the same. Therefore, we can see that those two sets are equal. So a few things for you guys to think about now. So one, can you explain in words why these two sets are equal? So how can you go about doing that in words? We'll talk about that more in class. And then I've got a few more on the next couple of slides. So I want you to draw Venn diagrams for these two sets. Here, because you have complements, you want to make sure to include the universal set. So you're going to include that big box outside of everything. And if you want to go ahead and draw that before class and take a picture, you can put the picture into the Jamboard. And I want you to see if you can come up with an expression whose Venn diagram would look like this one here. And I want you to go and think about 4-part Venn diagrams. So you can Google these if you want, look at the different images. There's a couple different ways you can draw this and figure out what your favorite is, or see if you can come up with a way to draw a 4-part Venn diagram on your own. And we'll share those out in class.